Time travel is one of the most captivating concepts in science fiction and has also intrigued scientists and philosophers for centuries. The idea of traveling through time, moving to the past or future, has sparked countless stories, theories, and speculations. While time travel is not currently possible according to our understanding of physics, it is a topic that continues to stimulate the imagination. The idea of time travel is often based on the theory that time is not a fixed, linear progression but something that can be manipulated or altered. In everyday life, we experience time as a continuous flow from past to present to future. However, scientists like Albert Einstein have proposed that time is more fluid and relative, particularly through his theory of relativity. Einstein's theory of general relativity suggests that space and time are interconnected in what is called spacetime. Space-time is like a fabric that can be warped or curved by objects with mass, such as planets or stars. The stronger the gravitational pull, the more the fabric of space-time bends. In theory, if an object could travel fast enough, close to the speed of light, for example, it could experience time differently than something moving at a slower pace. This phenomenon is called time dilation and has been confirmed by experiments where atomic clocks are placed on airplanes or satellites, showing that clocks in motion tick slower than those on Earth. This suggests that time itself can be stretched or compressed depending on how fast you move through space. A popular idea in time travel involves traveling to the past. The idea of going back in time has been explored in numerous works of fiction, from H.G. Wells' classic The Time Machine to modern films like Back to the Future. Many stories involve people traveling back in time to witness historical events, interact with past versions of themselves, or even alter the course of history. However, traveling to the past presents many paradoxes and challenges. One of the most famous is the grandfather paradox, which asks, what would happen if you traveled back in time and prevented your own grandfather from meeting your grandmother? Would you still exist to go back in time in the first place? This paradox raises the question of whether the past can be changed at all, or if it is somehow immutable, no matter what actions one takes. Another intriguing theory related to time travel is the concept of wormholes. A wormhole is a hypothetical passage through spacetime that could create shortcuts between distant points in the universe. Some physicists believe that wormholes might allow for travel back and forth through time. These tunnels, in spacetime, if they exist, could theoretically allow a person to enter one end of a wormhole in the present and emerge at another point in time, either in the future or the past. However, the practicality of such a journey is far from clear, as maintaining a stable wormhole would require exotic materials or conditions that we have not yet discovered or created. The possibility of time travel to the future is less controversial. Time travel to the future could theoretically be achieved through the effects of time dilation. According to Einstein's theory, as you approach the speed of light, time for you would slow down relative to an observer at rest. So, if you were able to travel in a spaceship at nearly the speed of light, you could experience time much slower than people on Earth. For example, you might take a trip to a distant star and return, having only aged a few years, while many decades or even centuries have passed on Earth. This type of time travel has been explored in various science fiction stories and is based on real scientific principles, though we are nowhere near the technology to achieve it. There are also more speculative ideas, such as the multiverse theory, which suggests that there may be multiple, parallel universes. In this framework, time travel to the past could be possible if you traveled to an alternate timeline, where the events you want to change did not occur. This avoids the paradoxes of changing the original timeline but introduces the concept of infinite branching realities. Despite the theoretical frameworks that allow for time travel, there are still many unanswered questions. One of the major issues is how to overcome the vast energy requirements to travel at relativistic speeds or create stable wormholes. The physics of time travel may also involve unknown quantum effects that we are yet to fully comprehend. Some theories even suggest that time travel might be limited by what's known as the chronology protection conjecture, a hypothesis put forward by physicist Stephen Hawking. This conjecture suggests that the laws of physics may inherently prevent time travel to the past to avoid paradoxes. Even though time travel remains in the realm of science fiction, it continues to captivate both scientists and the general public. It forces us to think about the nature of time itself, what might be possible in the future, and whether the past can ever truly be altered. Time travel, for now, may remain a fantasy, but the scientific exploration of space-time and relativity is real, and who knows what future discoveries might one day make time travel a possibility.